Today's show is brought to you by Vasion. You know print is one of the biggest drains on IT resources, but did you know there's an easy solution? Just eliminate print servers. They're resource intensive and likely the bane of your IT team's existence. Vasion Print, formerly known as Printer Logic, lets you simplify infrastructure and maximize resources by replacing print servers with direct IP serverless print. Reduce attack surfaces and secure your environment while still enjoying cloud-native flexibility that easily supports a hybrid workforce. Less complexity, less headaches, and less time wasted. And with built-in AI and automations, it's a solution that just works. See for yourself by scheduling a demo at vasion.com. That's VASION.com. Is Microsoft Unified Support busting your IT budget? Well, you're not alone. US Cloud is the global leader in third-party Microsoft enterprise support, and they're helping enterprises slash cost by 30 to 50% versus Microsoft Unified, all while getting faster response times from domestic engineers. No offshoring, no long waits, just expert support you can count on 24/7, 365. Trusted by 50 of the Fortune 500 companies and offering senior-level engineers with an average of 14 years experience with Microsoft technologies, US Cloud is the smarter alternative for premium Microsoft support without the premium price. Ready to make the switch? Book a call at uscloud.com to get started today. That's uscloud.com.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And for this week, our topic of discussion is trustworthiness of AI agents and just AI in general. And it's something I've been wanting to dig into for a little bit. And for that, we actually have Tanmai Gopal, CEO and co-founder at Hasura. So, Tanmai, why don't you give everyone a quick introduction before we get started, please?
Hey, everybody. Great to be here. I'm the CEO co-founder at Hasura. We are a company that helps people build reliable AI systems and intelligence inside their organizations. We spun up our lab just about a year and a half ago on the backs of a lot of data access work that we'd been doing prior to that. And now we're kind of really getting into the thick of what does it take to make AI actually work for enterprise. And so there's a whole host of interesting things to dig into there.
Fantastic. And like I said, our topic today is I'm going to combine, but we'll get into, if I should, reliability and trustworthiness, right? So let's kind of define the problem statement first. What's the problem we're solving for when it comes to both reliability and trustworthiness?
That's a really, really good question. Great way to start. So I'd say the way that we think about trustworthiness of AI, we don't necessarily need to over-define that term, but kind of really bring that back to the user and say, does the user ultimately trust their AI system to delegate an action to them or to trust the response of what they say so that they can go do further work based on top of that, right? What really matters with trustworthiness, and that's where it connects to reliability, is that there are different levels of trust. And that's that's the only important thing about trustworthiness, right? Which is that, for example, today, if I go to, not today, but let's say a year ago, if I went to ChatGPT, I could suddenly trust my AI to generate grammatically correct English sentences and for its ability to follow my conversation. That was new. When that landed, GPT-3, that was new. It was like, oh, okay, this thing, I can trust it to coherently maintain thought while it writes an essay. This is incredible. But that's it. That's all you could trust it with, right? And now we're kind of trusting it to starting to write code for us. We're starting to trust it to reason for us, right? And have that reason achieve a certain level of accuracy, right? But really, and this is the heart of the perhaps the most economically important question for AI. Does enterprise trust AI? Does business trust AI, right? Do you trust AI to do business critical things And that's really the most important thing, right? So we've kind of achieved this level where individuals trust AI because you figured out your trust equation, right? Like you have a friend and you kind of know how the friend works. And you're like, yeah, the friend is good for some things, the friend isn't good for other things, but as an individual, you trust the friend. Business does not like trusting friends. Business likes trusting lawyers and rigorous people and things that have a liability that you can attach to them. And so really the question is, when and how can we make AI achieve a level of trust that when AI says something, you're ready to take that and convert that to a business critical action, right? Let's a business critical decision, you convert that to an action. Or can you trust AI to take a business critical action for you? Can you delegate to that, right? That's kind of what I think about with trust. And in my mind, I maintain a very simple pyramid, which is this pyramid of agency and trust that you have, which is the same thing that you do for a colleague in your organization, right? You kind of start off like a intern where do I trust you to do the work that I tell you to do? To a colleague, which is do I trust the way that you think and answer my questions that I ask you? Like you're a respected colleague and I can ask you a question and you would have thought about it deeply, covered our bases, understood my context, and given me an answer. And then finally, an executive. Do I trust you enough to say, here's a business goal, figure it out, get it done, right? And we are not even at level zero of that trust pyramid. Like AI today inside our business, in any business today, is not even an intern that you can say, go do this thing and just have this guarantee that yes, it is going to go do that thing. It's not even there. It's a level below that bottom tier of the pyramid. So that's trust.
Yeah. And it reminds me too a bit of like in customers I talk to, I think the biggest challenge, especially for organizations in an enterprise context, is this concept of predictability. Like to tie a couple things you mentioned together, like take a version of GPT, like GPT-3 or GPT-4, the answers may be very different between the versions, but even in the models are a bit of a black box, so like the cloud models, if you will, of like if you ask it an answer, it might be pulling from a different data center, or it might have been fine-tuned or tweaked in some way, and you have no visibility into that. And that's a deal breaker for a lot of organizations. That if I ask it a question now and I ask it a question 6 months from now, it should generate the same thing, right?
100%.
And so I'll kind of move on and say, like, how is this trustworthiness measured? Because again, to bring back what you said, there is a certain amount of like in the trusting friends scenario, it's a bit of feeling, right?
Yep.
But for an organizations, a lot of times, I mean, it's much more concrete because there might be, say, for instance, legal ramifications behind something like this, right? And so how is at the enterprise or organizational level, how is this reliability, trustworthiness, predictability actually measured? Is it very concrete and black and white of it is binary right or wrong? Or is there some other way to measure this?
This is the heart of the matter. And the question, if I just take a quick step back, it's the same question of how do you measure trust for a business? So let's say you're running your cloud on AWS or Google Cloud or whatever it is. How do you trust them? And the way that you trust them as a business, not as a friend, is reliability. Their SLA. What's the SLA that they give me? How many times have they taken down my infrastructure? Have they corrupted my data? Have they caused a security breach? There are SLAs that you attach to different specifics, things that you measure, exactly what you were saying. And you expect those SLAs to be met. And that is your definition of reliability in the pre-AI era, right? Now we come to AI. And so for a business to trust AI, it must be reliable, and we must define what that reliability means for AI, right? And while I think the definition has not kind of come together yet for the entire industry, having talked about like 100 plus business leaders and now having kind of started to deploy reliable AI with customers in high stakes mission critical scenarios, for me there are two necessary measurements of reliability. The first measurement is exactly what you said, which is predictability. And this is kind of the measurement. This is this measurement of saying, if I ask the same question again and again, do I get the same result? Right? This definition of sameness is nuanced, because if it's a natural language output, it doesn't need to be word by word the same, right? But the reason has to be same. But if the output of the system is a table, report, something like that, then it has to be like word, number by number, accurate, right? So the first question is, if I ask the same question, if I ask it to the same task, does it do the same thing again and again? This is a measure of determinism. Is it deterministic? Because all my business critical processes, they run again and again. And so if I want you to do business critical stuff for me, you had better be deterministic in what you do, right? So that's kind of like the first part of predictability, right? The second part of predictability is more of a is a harder thing to measure, but um, it is still very it's something it's hard to measure generally, but it's something that anybody can measure individually, and that measurement is, can you form an intuition behind when it's going to fail? If you can't predict when the system fails, you're in trouble. So the system cannot, the failures cannot be surprising. It should not fail in surprising ways. Um, how do you measure this? You measure this with an eval set. That's what you do. You measure this by actual live interactions and usage of the AI system, etc. Right? But at its core, you have to have some way of measuring. Is it failing in surprising ways? Because if it is failing in surprising ways, you are maybe not screwed today, but you're definitely screwed tomorrow, right? And this is the whole host of like early adopters of AI who got into a lot of legal trouble a year ago, right? Where lawyers just made up cases and presented that to the court, and the court was like, "What even is going on?" Right? So it failed in surprising ways because they just assumed as humans that if AI can do this, well, it ought to do this as well. And this is like the biggest problem with AI adoption and churn today, right? Like, go to your Gemini right now, to your email inboxes, ask it a question, a simple question. What was the last Uber trip I took? You'll get an answer. How much did I spend on Uber in March? And suddenly it'll just be like, you'll have a WTF moment.
Sure.
Right? Now, if you've been building AI systems, you understand why. You understand why this is happening. It's because they do a RAG kind of thing where they search for them and they restrict the amount of results in the search. And then once it's restricted, it's not going to be exhaustive. You're not going to get a good answer, right? But this is just like even the follow-up question to that. When was my last Uber trip? And then you ask it another level of detail. So what time and where was it? And suddenly it gives me an answer from last year. Right? This is surprising failure, and this is really bad because you might think that you've shipped mission critical AI or shipped valuable AI, but if your AI system cannot present its failures in a way that are apparent, like that people can form an intuition around the people who use it or build with it, like that's just that's not going to work. So predictability is doing the same thing again and again, not failing in surprising ways. Measuring that is with an eval set and with regular usage that you do. But these are like deep product questions also that we need to answer in the AI product that we build for our stakeholders, that you are building internally for your enterprise users, you're building for your customers. How are you handling those two aspects of predictability? So that's kind of one thing to measure. There's another really important thing to measure that I talk about, but I wanted to pause here to see if that made sense.
No, it makes perfect sense. And it's the age-old saying, trust but verify. Right. Yeah. Around all of this. Now, I do have a follow-up question to all of this, though. I'm going to make it even one more level of complexity. In my mind, there's a difference between agentic AI and Gen AI. Mm-hmm. And the reason why I think about that is like when I think about this, like the Gen AI is tends to be more, I'll say, the creative side, and the results may be less black and white. Of course, if you're doing it to write code, it's very binary in its success or not success. But if I go to agentic AI, it's very deterministic. It did a function or it didn't do a function, right? And so is solving that problem of predictability and reliability, is the approach different? Because I know everyone's kind of almost lumping them together, and it's like Gen AI was 1.0 and Agentic AI is 1.1 or 2.0, right? But at the end of the day, when you really peel it back, to me, they're somewhat different. Is that true? What's your thoughts on that?
It's an absolutely brilliant question. It's a brilliant observation. It's a very good observation, and it's something that's very easy to miss, right? In all of these discussions. You're right that the current shape of agentic AI, with the idea with agentic AI is to say there's a goal that the agent must pursue and solve for. That's what agentic AI is. That's the difference from Gen AI. With Gen AI, you're saying, here's a thing, generate a thing for me. And we're chatting about the generation of it. With the agentic AI, you're saying their agentic goal is to achieve something and go solve for it. Right? Now, if your agentic goal is really simple, like your agentic goal is go to my emails and extract expenses from those emails. That's the agentic goal. You can build a really accurate AI agent that does that, right? Because it's just a program that you write. It doesn't do much. Goes through all emails, for each email, extract expense report, use AI to extract the number. Once you get all those numbers, you sum them up in a program. This is bang on, predictable, and reliable, right? But the challenge with agentic AI systems, and this is the challenge that everybody is kind of running through today, agentic AI systems are emerging. They are an exciting way to use AI, but they do not have if we just pursued agentic AI in the way that we're thinking about it right now, which is like write a program that does something, right? Why bother calling it agentic AI? Just call it software engineering that has AI functions in it. This is fine. I'm not trying to belittle it. I'm just saying it's software. And instead of having a sum function, a sort function, a length function, or whatever, there's another function, and this function is called summarize, or extract, or classify. There's a function that has some level of uncertainty to it, for sure, because you're dealing with natural language or images, but it's just a function in your code. Ultimately, you're shipping code, right? So the whole question, so that's kind of where that agentic AI, when you're really thinking of agentic AI as AI 2.0, the AI 2.0 version is not just a program that does something, right? The 2.0 version is you can actually solve a goal creatively. So you can then you can attach the agent to solve a more complex goal for you that requires reasoning in multiple directions, that requires dealing with data that comes in from multiple places and solving for a problem. That's a true AI agent, right? That would be the evolution of Gen AI into AI 2.0, right? The current method of using AI to write in a program to be more predictable, I wouldn't call that an exciting use case for AI. I would call that an exciting use case for software engineers, right? But for a business, right? Like you're the CEO of a business, or you're if you're running a business and you want AI to do things for you, the kind of problems that you want AI to solve for you is deep research inside your company, right? You want to say things like, why did I miss my transactions target yesterday in this e-commerce category? What went wrong, right? Why is this SKU performing worse than this SKU? And now go figure it out. Look at my data, look at unstructured conversations, go look at public web, go do a whole bunch of things and solve this complex problem for me. That needs to become business critical. Now, an agent can't do this reliably, because if an agent did this reliably, it would be too hard coded and specific, at which point it feels like it's an analyst just using AI, right? Like,
right.
Yes. The question is so simple, then you're just like, yeah, it's cool. AI is awesome. The analyst uses it. My analyst uses it to do stuff. But it's not the superhuman analyst, right? It's not 2.0. It's 2.0 in the usage of Gen AI. It's not 2.0 as the agent that solves things for you, that does research for you. Or if you convert that research into a goal and you say, figure out how I should reprice give me the new price that I need to present on my storefront, or tell me the products I need to put on my storefront based on last week's performance.
Yeah, that makes
Boom.
perfect sense.
That's
Yes,
hard.
I love that.
That's hard because you got to do the deep research to figure out how to solve this problem, propose the solution to the problem, simulate a bunch of ways to do it, and this might not be a predictable program. You know what I mean?
Yep.
You'd still run into the same problem of predictability, which is that if I ask you this question again and again, now I don't care about your answer being the same, but I do care about your rigor being predictable.
Yeah.
I care about your methodology being predictable in this case. I don't care about your output being predictable because with research kind of questions, look, if I ask the same question to three people in my company, I'm going to get three different answers. Doesn't mean I don't trust any of them. They just have different methods to do it. And I want to discuss with them whose methodology is the best and then get to the answer. So, but I want predictability in their ability to solve the problem, not necessarily the output, right? Which is interesting for agentic AI. So that to me is the difference between like Gen AI and agentic. We still have similar problems around predictability because you want intelligence, not software. If you try to redefine intelligence and put it back into a cage as software, you're absolutely right that predictability becomes easier because it's like software predictability. But if you want intelligence, you still have the same problem around predictability. Do you know what I mean?
Yeah. Yep. I love that. And I think that's a good spot to kind of like dig under the covers a little bit. And let's kind of talk about like data pipelines for a little while and how we can solve for this problem, right?
Yes.
Because in my experience today, many organizations, they'll take I'll use the term off the shelf model, right? Like something off a frontier model or something off Hugging Face or something like that, right? And they'll go and more than likely apply a RAG pipeline to it for customization. Sometimes I see some fine tuning, but I feel like most organizations, RAG seems to be the way to go these days versus fine tuning. But what is wrong with this architecture today? Like, how is that, say, less reliable or prone to hallucinations or unpredictability? Like, tell everyone a little bit about where the chinks in the armor are.
Yeah, this is a great question. So, O1 Pro, pay $200 a month, open it up, and go to your screen. And here's a question from a RAG benchmark that it won't work well on. And this question is, in the list of S&P 500 companies and their ticker symbols, tell me the employee difference, the number of employees that are different from the alphabetically 10th from the top to the alphabetically 10th from the bottom. So look at that S&P 500. There's about 503 companies. Get the first top 10, get the bottom 10th, look at those companies, get their employee things, and tell me the difference. Now O1 Pro will absolutely solve this. If you give it the two numbers and say, tell me the difference, it works. O1 Pro can solve this if you say, give me the alphabetically second from the top and alphabetically second from the bottom. This will work. If you say 10th from the top and 10th from the bottom, it fails. It takes 12 minutes and it can't even identify those two tickers. Forget the next step of trying to get the count or trying to get more information. Maybe it's not even a count. Let's not call it compute. We don't want it to do math. Let's just say, give me a summary or something, right? Tell me about those two companies. Tell me the technology sectors, whatever, right? It's a semantic task. Still doesn't work because it can't get to the top 10th from the top and 10th from the bottom. And this is connected to RAG because in this case, I don't even have to build a RAG pipeline. I'll just take the Wikipedia article. I literally take that article. That article is pretty small. It's 20,000 tokens. And I'll just paste it in O1 in O1 Pro's prompt, right? Like normally, if you would have built an enterprise search solution, what would you have done? You would have done a vector search. You would have searched for the articles in Wikipedia. You would have found, like in your knowledge base, you would have searched through the notes. You would have found the relevant note. You would have then picked up this note and given it to the model and told the model, ask the question, right? Like you would have done search and re-ranking and pipelines, but at the end of the day, you would have gotten the right article and you would have given the article to the model. You would have given the right notes to the model and asked the model to do stuff. So all your previous work does not matter. No matter how much you kind of optimize RAG and improve the search and improve the embeddings and improve the re-ranking and create a knowledge graph out of it, and you do a bunch of things, fine, good good job. But at the end of the day, when you get to this unstructured data and you give it to the model, O1 Pro that takes a lot of my money and causes global warming in tiny, tiny increments because of the number of GPU it burns, fails to tell me like what the 10th from the top and 10th from the bottom is. Um, and so the challenge is that when we are when so how do you form an intuition behind what's working, what's not working? Like why does it work when I do top and bottom, second from last, second from bottom, but fail on 10th? And like and it takes 12 minutes to do this. Like this is everything about this is unreasonable, right? And I think that's the core of the problem with RAG, and this is the number one complaint that everybody who is building with RAG has when their product or their solution that is built with RAG goes to actual users and goes for actual tasks. The biggest problem there's high churn, there's low adoption because it fails to handle the breadth and depth of tasks that people tend to throw at it. You cannot
Okay.
you something will work, but then you'll push it in some direction or the other and it'll just stop working because you're trying to use a general purpose like neural network intelligence to solve your day-to-day problems, and that's not the right way of doing it, right? Because in this particular, what's the difference between me trying to find out what the top company on S&P 500 by revenue is, or what is alphabetically first, or what is alphabetically 10th? Like it, to me, it doesn't make any, like, if you're letting me query S&P 500 data, then let me query it. Don't, right? Like you can't tell me not to ask questions. You said you're giving me intelligence, right? This is not software. It's not a UI where I can go to Wikipedia and click on the sort button and sort it. And then I can do it myself. It's super predictable. You're giving me intelligence, then you'd better be intelligent, right? And this expectation breaks down. And this is the biggest problem with RAG, right? This breadth and depth is the word that I hear from customers, that it's not able to handle the breadth and depth of data that we have or the tasks that people are throwing at it. The knowledge graph solutions don't work because knowledge graphs are brittle. Like I could have built a knowledge graph of S&P 500 articles, S&P 500 tickers, and then it would have answered the question. But what if my question was a little bit different?
Yeah, you can't
build the whole knowledge graph. Yeah, do I build a knowledge graph for every single question that you ask me?
Right.
No. So yes. That's kind of why like the RAG approach does not work for when you want to achieve this kind of reliable general intelligence, right? General purpose intelligence on data. This approach doesn't work, right? If you gave this to a software engineer, if you took your agentic approach that you were talking about, it would work. What would they do? They'd take the article, they'd write a program to get the list of all the tickers. They'd put it into an array, they'd sort it, they'd get 10th from the top, 10th from the bottom. They'll go to the next article that has, the article on the 10th company, article on 10th from the bottom company. They'll use AI to extract the employee count. They'll write it in Python. You'll get a number. And so you can build an AI agent for just this problem. But do you want to? Like literally just for this problem? Like is that the purpose of my life, is to build AI agents to answer like ticker from the top, ticker from the bottom, what's the employee count difference? I can make it super predictable and reliable, but am I gonna build this one agent for you? No, right? So that's the problem.
Yeah.
Right?
Yeah.
You can build the agent and there are few use cases that might be that valuable, but it's not general purpose enough to warrant introducing intelligence into my business.
Yeah, that makes perfect sense. And Tanmai, let me ask you this then too. Like, let's talk about Sora and PromptQL for a little bit as well, because like as I understand it, like what we were kind of talking about too is like this decoupling of the query and the query planning from the actual execution, right? And like it really is at the end of the day coming up with a very deterministic AI workflow, right?
Yep.
Now, I completely admit that's kind of a bit of a mouthful of like if you had to hit like one sentence, what is it? It's like, oh, it's this. It's like, okay, wait a
Yeah.
second. So can you kind of break down exactly what
that
that
is.
means and like
Yeah.
how does it fit into like, okay, I've got a traditional RAG pipeline today. Is it something that
Correct.
is inserted into the middle of the RAG pipeline and serves as an abstraction
Yeah.
layer? Like tell everyone a little bit about this next step and how it could potentially solve.
That would love to chat about that. It's been something that we've been breaking our heads over the last year and a half, and so excited to share the research work that's happened here and the progress that we're making. Right. So, the first core simple idea and insight was just saying it's exactly going back to what you were saying, Aaron, earlier, which is like um, the only thing that you can control in an AI model is not how it works, but it's kind of what it generates because it's generative. Like that's all you get. And so what we did was we decided to kind of move the cheese a little bit and say, what if I use Gen AI to generate a plan, not the result? Don't solve the problem for me. Come up with a plan to solve the problem. So if I give you this Wikipedia benchmark article, whatever, come up with a plan for how you do it. So you'd be like, I'm gonna search for this, and then I'm gonna do that, then I'm gonna extract this, then I'm gonna do the difference here, and then I'm gonna get this data out. Right? So you come up with a plan for how you want to do things. And what you hear about when you hear agentic RAG, it's like starting to do things like this, right? But then agentic RAG suffers from other problems, which is like if you need to access structured data or mixed structured data, then that becomes hard because agentic RAG is search-based retrieval. The idea is to search for something and do stuff, but you now need to mix in structured stuff. So at the end of it, regardless of what the technique is, the idea is, can we get AI to generate a plan for us that tells us what to do? And that's the discussion between human and AI is kind of the perfect plan. And then the second part of what we do is now we have a way to execute this plan as if it was software. So it's fully deterministic. Once the plan comes into existence, we say goodbye, LLM. Thank you for your services. You pause it, and then you just run the plan as if it were code, as if it were Python or SQL. You just like it runs in a deterministic way. So our invention here is this language, this domain specific language that can represent any AI plan, regardless of how complicated it is. So any agent that you were talking about, that agent can be represented in this language. And this language plan can be generated by other LLMs. So the LLM is just generating an agent on the fly for whatever task you give it. What does this agent do? Well, it could do search, it could do structured retrieval, it can look at unstructured documents and extract a knowledge graph out of it. It can join data, it can compute stuff, it can do all kinds of stuff, right? That it could anything that you would have hand coded a perfect agent for. But it's a plan for an agent. It's not actually running the agent. As soon as the plan for the agent is available, we now deterministically execute the agent. So now we don't ever have to be worried about the fact that, oh, one pro can think about how to do it, but can't actually do it. I have a billion rows. How's the one pro ever going to work? It's not. Don't worry about it because that's just going to run like a machine. Right? The plan was to go filter a billion rows and look at a billion emails and see how many of them are a security risk or not. Cool. That's the plan. That's not the work. The work can just be done separately, right? So that's kind of the key piece here. And so how it fits into RAG is if you have prepared an unstructured or search index, right? And a search method that can search through that index and pick up relevant things, then instead of now you building manually the RAG kind of algorithm that says go search, then go re-rank, then give it to LLM, get answer and share answer with user, that bit of code, those 5 lines of code, that gets replaced now with what we call this data agent, right? Which is this prompt QL layer, which will figure out how to use this amazing search function that you created or you invested time in creating a knowledge graph. It'll use all of that. It'll just figure out how to use it, depending on the question. That's what this does. And this gives it the reliability, but also the kind of explainability. You can actually see what it's doing. And then you can be like, no, you screwed up. That was bad search. When I said travel, And you only thought travel means you extrapolated that travel search into only hotels and reservations. You didn't include taxi and cab. Now you know why it's failing. You're not kind of stuck in this black box of like, I asked it to search for travel expenses and it didn't find my Uber trips. This AI sucks. Now you don't do that. Now you can ask the AI.
Sure.
It's like, bro,
Sure.
why did you mess this up? I definitely had Uber trips last month. Why is that not in my expense report? And the AI is like, I made a search for hotel stuff. I get it. I'll add this to the search terms. Should I create a new plan for doing this? I'm like, yes, please. And then it works, right? So it just completely flips that experience because the generative output is the plan. And there's a lot of like work to make sure that this plan can be human understood. You don't have to look at code. You just literally look at like, you're talking to a colleague. The colleague is like, I'm going to search through emails in March and I'm going to search for these terms and then I'm going to get you the expenses. And you're like, thank you. I trust you, human. You've done a good job. This is the equation that you have with the AI now, instead of pray and get an answer and it's not correct. And then you're frustrated, right? So that's kind of what the approach is, if that makes sense.
No, it's perfect. I love that. So we'll close out there then. I think if anyone is kind of interested, what's the best way to reach out to you or to just get started in general?
Feel free to reach out to me on LinkedIn and the Twitters, and that's or X. But that's where I'm around. But if you are interested in kind of some of the AI and product stuff, the best way to do is just head over to the website and reach out to us. We've been doing an interesting thing where instead of the usual like you contact us and a salesperson jumps on, when you reach out to us, the person that you'll talk to is actually somebody who's been deploying these AI solutions for people. And so you can expect to have a pretty sophisticated conversation with somebody who will tell you what the reliable AI story is, whether it applies to you or not, and really kind of like get to the meat of solving the problem. And then usually that's how we take it forward. The one thing I do want to add is I've just loved speaking with customers over the last 2 weeks because of this kind of approach that we've nailed, which is like Aaron, for example, if you come to me and you're like, I'm thinking about trying to make AI work for this and it doesn't work well. And then we're like, okay, cool. Connect us to your data. Give us 50 of the hardest questions that you want to do. And our agentic semantic layer and our approach will give you more than a 95% to 100% accuracy within 3 or 4 days. And so that literally just ends up being your evaluation. You're like, here's my data, here are my questions, make it happen. And then we turn around in 3 days and you're like, boom. Literally like I don't want to say 100% accuracy because it's hard to say that with a straight face, but like our SLA is greater than a 95% accuracy, right? So you just look at that and you are just like, it works. This was the dream. This is why we've been investing $1 trillion into data centers and GPUs, and now this works. This is accurate. And so that's what the experience is like. So feel free to reach out in a technical context or just to shoot the breeze on AI stuff. Happy to chat anytime.
Fantastic. Well, Tanmai, thank you very much for your time today. And I'll kind of close us out there. So on behalf of Brian and myself, thank you very much to everyone for listening this week. And of course, as usual, if you can and you enjoy, please tell a friend. Please leave us a review if you can leave a review wherever you get your podcasts. And also, we're always welcome to feedback as well. show@thecloudcast.net. And everyone out there, thank you very much for your time this week. And we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.